So we already saw a very nice technique before, namely how to factor a trinomial such as this, right? Where the leading coefficient was 1. Now, what if it wasn't 1? Well, how do you handle that? That's what we're going to see today. I mean, there are other methods, I think, in the book, but I'm going to show you one that's based on factor by grouping. And this is actually the procedure. Of course, you always, and again, we're assuming A here is not 1. So basically what we do is this. I will demonstrate through examples. So first, we find the GCF and factor it out. Okay? Here, actually, the GCF doesn't have to be 1, okay, because you have a leading coefficient that's not 1. So it could be 1, the GCF, but it doesn't have to be. What you want to do is you're going to find two numbers. So you're going to calculate the product A times C. You're going to multiply them. You're going to find two numbers whose product is A times C, and the sum is B. B is the coefficient of X. Okay? Right? A is the leading coefficient. C is the constant term. You multiply those, and you want two numbers whose product is A times C, and the sum is B. Then you're going to replace B by that sum here. In doing so, after you distribute X, you're going to have 4 terms. And what happens when you have 4 terms and you want to factor? Factor by grouping. So again, this is in the notes which I just sent out. I'll post the notes as well on Blackboard. So anyway, let's do some examples of this. So it is more involved than this case, but that's to be expected because the leading coefficient's not 1. So let's consider now our first example. Now, right away, you should be able to see the GCF is going to be 1. How do we know that? Well, there's a non-zero constant term, right? So there's no X here. You can't factor out X. So you take that M to be 0. Notice also that 5, 11, and 2, I'm not going to list the factors, but hopefully you can see that the only factor they have in common is 1. So your GCF in that bx to the m would be 1 times x to the 0, which is 1, times 1, which is 1. Okay, so there's nothing, in other words, we can't factor out any. So the GCF is 1, so we just move on. Now, comparing the two, right, we can see that 5 is our A, 11 is our B, and the constant term 2 is C. And that's what I have over here. So now we know what A, B, and C are. We apply that procedure, right? We're going to multiply A times C, and we want two numbers whose product is A times C, and the sum is B. So in this case, 5 times 2 is 10. So we want two numbers whose product is 10, and the sum is 11. Okay, or if you want, filling in those blanks like I did with the case when the leading coefficient's 1, we want two numbers that fill in the blanks here. Okay, well, what two numbers are going to pull that off, though? Well, how about this, 10 and 1? That works, right? 10 times 1 is 10 itself, and 10 plus 1, of course, is 11. So these are the two numbers we're going to use. So what do we do now? We have 10 plus 1, right? We're going to replace 11 with 10 plus 1. And that's actually what I'm doing here. From here, I'm replacing it with 10 plus 1. Then I'm distributing that x. Let me show you. So then what I'm doing is I'm distributing that x. Doing so, we get this. As you can see, okay, right? We have 10x plus 1 times x, but 1 times x is just x. So now you can see we have a polynomial that has 4 terms. So now we're ready to use factor by grouping. Remember, you can only apply factor by grouping to 4 terms. Excuse me, to a polynomial having 4 terms. And now we have one. So that's what we're going to do. And again, just like before, it should be easy to see here that the GCF is 1, mostly because there's a non-zero constant term, the 2. So we can't take x out. So m is 0. We have a coefficient of 1. So it's really just like the first example we saw today. Since we have a coefficient 1, the only common factor among these numbers, the coefficients and the constant term, the only common factor among the numbers is 1. So the GCF is just 1. What do? Remember, just like with factor by grouping, we form the 2 groups here. Like so. And now remember, what do we do next? We're going to factor each group, we're going to find the GCF of each group individually. So I put it up here again for convenience. But we're going to get the GCF of this thing. Okay, well, how do we do that? Well, notice the smallest exponent of x is 1. Okay, so our m then, I didn't put it here, but the m would be 1 then, right? Remember, the GCF is bx to the m. So m in this case is 1. And 5 is a factor of 10. So it's just like what we saw earlier with 9 and 36 and 4 and 16, an earlier example. Since here 5 is a factor of 10, 5 itself must be the greatest common factor of these coefficients. So altogether, we get this as our GCF for this thing. That's wonderful. Now that we have found it, what do? Factor it out, right? That's what I'm doing here. Factor it out. And again, when we factor, we divide because we have to get what's left over and so on. And so we get this. Now, next, although hopefully you can see by now, but next we would have to find the GCF of the second group, x plus 2. But hopefully, hopefully you can see right away, although it's in the notes, I guess, so I guess that's okay to do. You should be able to see right away that the GCF is 1, right? We have a non-zero constant term. A non-zero constant term. So m is 0. The coefficient of x is 1. So as before, the greatest common factor of the numbers, the coefficients, and the constant term, that's 1. So we get b is 1, m is 0, and our GCF is just 1 for this. So because it's 1, we can't factor anything out. And also because the second and fourth term are the same. So really, we don't factor anything out of the second group. But that's actually okay, right? Notice that after factoring these 2 groups, right, there's a common factor here, x plus 2. That's in both of these. That's what's in parentheses. That's in both groups. And that's what we want. So that's what we factor out. And that's what we're doing. we have x plus 2. And we keep factoring, and we factor that out, as you can see, just like before. Then what do we do next? We divide, right? And here they cancel. That's how we get 5x. Here you have something over itself. That's just 1. So altogether, the original, which was this, turns out to be this guy. Turns out to be this. This is how we factor it. So that's an example of the AC method. And it is a generalization of what we saw earlier, right? Because here the leading coefficient is not 1. You could actually apply this technique if the leading coefficient is 1. It's just more work than necessary. All right, that's good. Let me just pause this. Okay, let me just pause it for a second.